Okay, I'm guessing you got some answer that had a square root when you solved this one. No, did it work out nice? Awesome. Okay, so here's how it works. You have an x and an x plus 3 to fix. Why do I have to fix them? Because you want to clear fractions. Then you can solve. All right, so to clear this thing, I'm going to multiply by x and x plus 3 everywhere. People that are reading a book right now, time to get back to me again, please. This is important that you get. I know you may even already think you have it and I'll have it all figured out, but I want you to pay attention. Okay, here we go. So this x cancels this x, and then I'm left with this, which is 2x plus 6. It's usually the distributing that gets people. Or if this is negative, that's another thing that gets people. Because if that had been negative, it would need to distribute onto both things, and that's a classic thing people forget. So watch out for that. Okay, plus that cancels that, and I have x equals, let's see, oh, this one, actually, when I factor it, turns into x and x plus 3. So that way, that and that can cancel that and that. And I have a 4 left. Yay, that wasn't that bad. In fact, that wasn't even a parabola, was it? It doesn't even quadratic. All right, usually they work out so they're quadratic. This is 3x, and then I'm moving that 4 over to this side, subtracting 4 from both sides, plus 2 equals 0. I don't even need to do that. I just need to get x alone. So 3x equals negative 2. X equals negative 2/3. Raise your hand if you had that one right. Okay, awesome. Now, if that had been a quadratic, which they usually are, I could have made it a quadratic by putting an extra x, like right here, for instance, making that 2x. And then this would have been 2x squared plus 6x. Okay, and then when you have a quadratic like that, you just use the quadratic formula at the end to solve it, if it doesn't factor. All right, so that's all the old stuff. So what's the new stuff? The new stuff is when you are solving an inequality, let's talk about what would be different. Let's say you had this. What is going on here? Okay, first of all, do you get that when you have an inequality sign, do you remember with an inequality sign that you need to have an inequality, like a number sign on each end of a number line? Do you remember doing number lines and testing intervals? That's what we're going to be doing again. All right. What do you think? What would you suspect would be an important spot on said number line? Yes? What? 2 is a good guess, and I might or might not be right. There's a more important spot. We've been looking for these things a lot. Yes? Why would 0 be important? Okay, I kind of agree that 0 is important, but it's not important in that context. If I put a 0 in right here, do you get that that doesn't really cause any problems? What do you think? -3 was what I was looking for. That is correct. I know playing Read the Teacher's Mind is not a fun game, but that is an important spot. Okay? Why is it important? Because the whole thing crashes right there. Okay? So -3 is kind of important from that perspective. So I'm going to pick this spot right here to be -3. Okay? Would you agree that the function cannot be -3? Now the only question is whether or not it can be other things. Okay, so let's test some things on the other side of -3 and see if there would be any other important spots here. Like, let's try, this would be -2, this would be -1, this would be 0. 0 is always a nice thing to test. Let's say we actually put in 0 into our equation. You mentioned before, one of you guys, that 0 was important, and it is. If I put a 0 in right here, is 1 over 3, because 0 plus 3 is 3, is 1 over 3 greater than 2? Is it or not? No, so it didn't work there. That didn't work. Now, if we've got our roots found correctly, then I just need to test one thing over there, and we'll find out that the whole thing doesn't work. Let's try some just for fun. Let's see if there's something bigger, like 100. Let's say I put in a 100 right there. Do you get it still wouldn't work? Let's try one more thing. How about -2? How about if I put in -2? I'm testing a whole bunch of spots here. Say I put in -2. -2 plus 3 would be 1. 1 over 1 is 1. 1 is greater than 2. No, still doesn't work. Do you get how it doesn't work anywhere over there? Okay, so that side doesn't work. Now, we go to the other side. I bet you we'll start finding some things that work on this side. How about negative, well, we already tested -3 itself, and it crashes the whole function. How about like -4? Let's test -4. So put a -4 in here. -4. -4 plus 3 would be what? -1. Is 1 over -1? That's -1. Is -1 greater than 2? Oh, that didn't work. All right. Is it possible that there's no number in the entire universe that would make this work? Yeah. All right, so if you test on both sides of the number line and it doesn't work, it's possible. There's just no solution. All right. So this was kind of a weird one, but it told you a couple things. First of all, when you're doing inequalities, you got to find the important spots on the number line. And we figured out that that -3 was an important spot because it crashes the whole function. All right. Let me try one that's a little more, I don't know, a little more intense or a little less intense. I'm going to pause for a second while I find a good one here. Okay. What if we didn't have the fraction part? What if we just had this? If I'm going to try to solve this, I've got to know where it works, and there's a range. Anytime you have like a greater than sign, that tells you the answer is going to be like a range of numbers, like from here to here works. So we need a number line. So right away I'm thinking, let's make a number line for this. And let's figure out what the important spots on the number line are. Judging by that last one we did, any guesses this time? -3 is important, and 4 is important. So let's put on a -3 and put on a 4. Just as long as you have the smaller one to the left of the bigger one, we're fine. I do not need you to put every single mark on the number line. Those two are obviously important spots. Now, are they necessarily automatically spots that don't work? No, they can be spots that work, but they're important spots anyway. Now let's actually, in our head, stick this in for a second. If I stick in the -3, I get 0. Is 0 for this whole thing greater than 0? No, so it does not work, okay? I'm leaving it as an empty circle then, because it doesn't work. All right, now I'm going to put in the 4. If I put in the 4, same thing's going to happen, right? 0 is greater than or equal to 0, doesn't work. Okay, empty spots. Now we have to test all the intervals around it. So I want you all, you guys were the worst at this. On your test, it was the thing I marked wrong the most. It is every year, but the testing the intervals part. I want you to try to grab a number from in here, from out here, and out here. And I want to all test the same one just so there's no chance that some kids pick badly. This one I want you to test 0. Here I want you to test 5. And here I want you to test -4. Test those 3 things by sticking them in the equation and see if they work. What do I mean by work? It has to actually be greater than 0 if it works. Okay? Try that. I'm going to pause for a second while you test those intervals and see where it works. All right, so put somebody on the spot. Mr. C in the back row, tell me one of them. Just tell me how you talk me through one of them. Okay, you're going to use 0. Plugging in 0. 3 times -4 makes -12, and then what? -12 is not greater than 0. I agree. That part's out. Raise your hand if you had the same thing. Okay, good. And the back row, Miss D. You're going to check 5 for me, okay? What do we do? Put a 5 in the x's. Now what? Eight times 1, excellent. And 8 is greater than 0. 8 is greater than 0. It worked. So this works in this area. How do I show that it works? Shade it in. Yep. All right. And then the last little section, Miss M. Tell me how to do it. I'm plugging in -4. And does it work? Well, what do you get when you plug in -4? -1 times -8, which makes +8. And 8 is greater than 0. It worked again. Would you agree? All right. How do we write our final answers? As intervals. So, -infinity to -3, union 4 to infinity. You remember that? Remember how to write them that way? Okay. That's all there is to it. What's the difference? What are these things called? Well, these things are solving something algebraically. Solving inequalities algebraically. So, I guess that's the main idea for today. I'm going to pause a second and see if there's anything else I need to teach you. Okay, so the only thing I found was we need to be able to solve these if they aren't factored. Like, let's say it was x squared plus 3x plus 2 equals, or no, greater than or equal to 0. Okay, so factor it. Everybody factor that thing. Let's have you go through one here for practice. Remember, you'll have to have a number line. And this time I want you to note I said or equal to, which changes the equation a little bit. Changes what you're looking for. You're trying to find if it's less than or equal to 0. So this little sign right here says you should make a number line. You really should. Pause while you do that. Okay, so here we go. Hopefully you said x plus 1 and x plus 2. So there were obviously two important spots. Now this one's going to act different than the last one, though. I hope you noticed there was a difference. How many of you noticed something different this time? Only a few of you. All right, then a lot of you messed it up. We'll see. All right, if this is at -2 and this is at -1, we would all agree that they're important spots. Now, what I mean by different than last time is that this time, -2 and -1 actually work. What do I mean by that? They actually, when you put in -1, you get 0. Doesn't that just cancel all of this? Yeah, it makes it into a 0, but 0 is greater than or equal to 0. It works. That means that this is a filled-in spot. You remember how that worked if there's an or equal to sign? Do you remember that being a filled-in spot from our last unit when we did this? Good, I'm glad some of you remember that. So these are both filled in. How many caught that before I said it? Ooh, that's most of you. Good. Okay, now let's check some other spots. This is the pain in the neck one because it's a decimal. Okay, -1.5, right between there. Okay, now if I'm going to put in -1.5, I'll put it in here and here. Do you remember that you don't actually have to have the answer? All you care is if it's bigger than 0 or not, and therefore we just need whether it's positive or negative. Miss W, could you shut that door for us? Man, I guess there's 2 W's. All right, thank you. This is positive. No, it's negative. Sorry, that one's negative. This one's positive. Do you get that all I really care is that I have a negative times a positive and therefore a negative answer? I don't even need to get the decimal. Just waste my time. I know this comes out negative. Is a negative number ever going to be bigger than or equal to 0? No, it does not. There we go. Cross it off. And do you remember then that usually both ends work then if it doesn't work in the middle? But can you always trust that? No. You need to double check because we like to include the exceptions in the test. So I would check both ends. What's something bigger than -1? Maybe 0. Let's test 0. I put a 0 in. I'm going to clear this up a little bit here. Getting really messy. Okay, I'm going to put a 0 in now. 0 and 0. Positive and positive makes positive, and that's greater than 0. See how quick that is? Worked. And if I put in a negative like -3, Now all of a sudden it's negative and negative, and that makes a positive, which is bigger than 0, so it works. All right, so final answer, negative infinity to negative 2, bracket, where some of you might have had a parenthesis before, union bracket negative 1 to infinity. Those make sense? Okay, the last thing you got to do is graph it with a calculator. I asked you before, would you grab a graphing calculator? If you don't have one, borrow one from me. Make it fast, please. And what I'd like you to do is graph the one that's on the board right now. X squared plus 3x plus 2. I want you to see how that would have looked on a graph. X squared plus 3x plus 2 is greater than or equal to 0. Now, I know some of you are just going to graph one equation. There's actually two equations here. Do you remember that we have y1 being on this side and y2 being that side of the equation? You should graph two equations here. All right, so I'm going to go up to y1. I'm going to put in x squared plus 3x plus 2. And then I'm going to go to 0 for the other one. And then how do I say that the one is bigger than the other? Do you remember that? Remember Mr. Mr. F actually? Go ahead, what do you do? Vars. Y vars. And I bet you're going to say y1, aren't you? Y1. How the heck do you do greater than? Second 0? Oh, you're going to catalog. Okay, that'll work. There is a faster way. Does anybody know the faster way for the greater than thing? Yes, ma'am. Yep, it's right above math. Test. It's a thing called test. It is a lot faster. Now, granted, catalog's awesome because it has every single thing you ever would want. But if you want to get there faster, it's under the test menu. Okay? So I'm going to say that, and I'm going to say, what is it this time? Oh, it's a greater than. See, greater than 0, greater than or equal to, just to clarify. That one. Enter. And then I got to say y2, which is under vars, y vars. Function, be careful though, this one's y2. Enter. Now, if I actually hit graph, hopefully I can see the raw beauty. What the heck? Oh, there we go. Okay, here comes the other line. Now, what is this last thing? Can you tell what it's telling me? It's telling me that I should shade that last black line there. I'll make it green now. That's telling me to shade on the outside. Okay. So, and how am I supposed to know what my two important points are? You can use second calculate intersect to see what that important point is and that important point is. So if you were doing this just completely with a graphing calculator, you'd still want to make a number line. And you draw your number line and you'd say, okay, I want this to have two important spots on it. I can't tell what they are yet, but I'll use my calculator to find them. And I'm going to shade on the outside because that's that black line that ran through at the end. Tells me where to shade. Okay. Now, where is it? I'm going to use second calculate intersect in just a second here. Let me clean this up. Okay, second calculate intersect is number 5. And then I want that line and that line. Careful, I don't want the black line, right? And then I'm going to go over to where they hit, which is about there. And that tells me their intersection was at -1. That's the way you could have done it with graphing. All right, I think you've learned everything you need to know for today. And your assignment is that one we were working on together there. Have a good day.